Hi, in this video we are going to talk about object-oriented programming in C++. Object-oriented programming is a way to build a software or a program. In object-oriented programming, we see these two terms a lot, class and object. A class can be considered as a data type. It's different from primitive data types like int, float, char in a way that it can also have functions. An object is a variable of this data type. For example, we create int x. Int is the data type, x is a variable. Similarly, a class is a data type and an object is a variable of this data type. The programs that we have been writing so far, they were functional programs. What we were doing in those programs, we were writing some functions. Main was a function. We were taking some input, doing some computations and producing an output. These programs are good, functional programming is good when you have small tasks to do, like your lab assignments or maybe a script in your company to do some small automations. But if you want to design a complex software, a software which has many entities and these entities interact with each other, they call functions of each other. In such scenarios, it's not a good idea to design in a functional programming way. Object-oriented programming approach to build programs or softwares in such scenarios is always preferred. It's always preferred when you have a complex system with many entities. But remember, if you have a simple program or a simple automation script, then it might not be a good idea to use object-oriented programming. In C++, we can program both ways. We can either program in functional style or we can program in object-oriented programming way. C++ supports C-style functional programming and it has all the features for being an object-oriented programming language. Imagine a situation where you want to build a software for students, teachers and subjects. Every student has a name, some subjects that he's enrolled in. Student has marks associated with him. A teacher has name, teacher has subjects that the teacher is teaching. Every subject has a name, subject has a weightage that decides student's grade. This software reads data from certain files or maybe certain database. It processes this data and then answers users' queries like what is the grade of a student, what are the details of a student, like subjects taken by a student, details of a subject. How would you design this software if you do not know object-oriented programming? You will probably write an int main function. You will make different arrays like an array of student names, an array of teacher names, an array of subject names. You will read these data in different arrays and then you will answer these queries using these different arrays. This style of programming becomes really complex because whatever functionalities I want to achieve, I'll have to pass multiple arrays to individual functions. And then there are many arrays. Some arrays are representing teacher names, some arrays are representing subject names, some arrays are representing student names, and then there are more and more variables which are being passed across multiple functions. Imagine a different way of programming where you have a student data type, a student class which has all attributes of the student like student name, student subjects taken by the student, student marks, and the functions that are performed on the student like get grade, get marks in a particular subject. Similarly, you have another class for the teacher which has data and functions to be performed on the teacher class. You have one more class for the subject which has data and functions to be performed on the subject. This way of programming looks very clean. You can extend this way of programming and have more classes in future. You can individually test these different classes. You can add more functionalities to these classes later if you want to store more information about the student. You can individually change functions of individual classes if you want to change any representation. For example, in future, if you want to change this representation of storing the student name instead of character array to a string in C++, you can change in one student class. So this programming style gives you a lot of flexibility when your software is big and it's going to get bigger with time and you want to make it maintainable. There are more advantages of object-oriented programming. In the previous example of the student, imagine that we had many features which were common in student class and the teacher class. Features like name, address, ID, these are common in both. So what we do is we create a person class which has these common attributes and common functions like get address, get name, set address, set name. These common attributes are put in a separate class and then these two classes inherit from this class. So inheritance is a concept, one of the pillars in object-oriented programming where we avoid rewriting the same code. So we can make a person class where we put common attributes, common functions. These two classes inherit from this person class and they do not rewrite the same code at multiple places. So there are more things, more pillars of object-oriented programming like encapsulation, abstraction, polymorphism. I'll talk about these things after discussing few simple examples. Let us take a look at this program. I have a class complex which has data members like real and imaginary. So a complex variable in mathematics has a real part and an imaginary part. And it has certain functions which can be performed on the objects of this complex class. Objects, please remember, are variables of this complex data type. When you write a complex class, it creates a data type. And this data type is different from data types that we use to create in C programming. This data type has multiple data members and it has functions which operate on these data members. So this data type has real part, imaginary part and the function to print the complex number. There might be more functions like add one complex number to this complex number, multiply a complex number with this complex number. Just to keep things simple, I have just added one print function. If you take a look at this program, you will notice that there is one more function whose name is same as the class name. Such functions are called constructors in object-oriented programming, and they are similar in almost all programming languages like Java also. These constructors are called when you create an object of these classes. So the idea is to have some common code to initialize variables. This helps a lot. Imagine doing it in functional programming. You were creating different student arrays and while reading from the files, maybe you were doing some error checking like, student name should not contain special characters. You can put all that code in this constructor, right? Imagine a student constructor. You could put all that code in the constructor of the student class to handle all the errors. And if your business logic changes, for example, you want to also ensure that student name does not go beyond certain limit, you just have to go to that student class file and you just have to modify it there. So this is a constructor of the complex class, which is called when you create a variable of this complex class. Here in the main program, I have created a variable of complex type C1. C1 is an object of this class. This object passes two parameters to the constructor and this constructor is called for this class, and this particular complex number C1 now has values 10 for the real, 15 for the image, right? And when I call C1.print, it prints the complex number. So what we get here is 10 plus I-15. In this coding example, you must have noticed that private and public. What is the point of these? Private members of a class are the members that cannot be accessed outside the class. What do we mean by outside the class? Functions which are inside the class, like print function, this complex constructor, and maybe more functions, they can only access private members. If I try to access c1.real in main function, I will get compiler error. Suppose I add cout c1.real. Then this program will throw a compiler error. Now you must be wondering, what is the point of having private data members? Consider our previous student class. We had marks as a member of the student and say that maximum marks for a student can only be 100. Now we have a function set marks or give marks. This function, whenever somebody passes a parameter, checks whether these marks are less than 100 or not. If somebody passes a mark to be set as more than 100, this set marks function inside the student class throws an error, says that invalid marks. And we allow our users to access marks only through this set marks function because we have made marks as a private. What is the point of making private? Your student class object would never go in invalid state. Somebody cannot create a student object, say S1, and cannot do S1.marks equal to 150, right? Because if somebody does S1.marks equal to 150, then that part of the code is going to give compiler error that marks are private. So whenever somebody wants to set marks of the students, they have to use set marks function, and your set marks function does sanitation checks. It does validations that marks are valid or not. So this technique of making few things private, making few functionalities private, and showing only the things which are accessible to the public is called abstraction. You hide internal details of your class. You don't want to tell the users of this class how things internally work. You only want to say that this class supports these functionalities. This is called abstraction. Encapsulation is simply bundling the class, data members, and functions together. So the whole idea of creating a class which has data members and related functions together is called encapsulation. It's different from functional programming, where we had data members separate, functions separate. We were passing these data members to the functions to do some computations. So the idea of encapsulation is to put related data and functions together and create a class. Abstraction, hiding internal details, hiding the internal functionalities. For example, if you are using a coffee machine, you only need to know that if I press this button, coffee comes out. You do not need to know how this machine internally works. If you are driving a car, you only need to know which button to start the car, how to use accelerator, how to use brake. You do not need to know how these things internally work. What happens inside the machine when you press the accelerator? What happens inside the machine when you press the start? You only need to know the public interface of the car. You only need to know only public interface of the coffee machine. That's the same idea applied in object-oriented programming. If you are making multiple classes, multiple people writing the big software, they make some data members private and they provide only public interface that can be used by other people. And other people or other classes do not have to worry about internal details, how these things are internally implemented. They only can use them directly. So we have talked about encapsulation, we have talked about abstraction. Inheritance is one more important concept, and we talked about that also, that we create a person class, we put the common code in the person class, and then these classes, teacher and student, they do not have to rewrite that common code. For example, there is an address and there is a particular way in your organization to print that address. So print address can be a common function which can be there in the person class. Do not have to rewrite in the student class and then the teacher class. This is called inheritance. There can be more examples of inheritance. For example, say if you are designing MS Paint, then you will have a shape class. Every shape has color, width of its edges, location, and then these members can be inherited by multiple shapes. You can have a rectangle, you can have a triangle, you can have a circle. All these classes, they share the common basic features of the shape. So you do not have to recreate those data members. You do not have to recreate those functionalities. For example, change color, and all these functionalities can be put in the shape class. The last important thing about object-oriented programming is polymorphism. Polymorphism is one name, multiple functionalities. Polymorphism is of two types, static and dynamic. Static polymorphism we have already discussed. We talked about function overloading. We can have one function named max which can find the maximum of two integers, and we can have another function with the same name which can find maximum of three integers. Similarly, we can have a function sum which takes two integers and find the sum of two integers. We can have one more function sum which takes three integers and find the sum of three integers. We can have one more function sum which takes an array and finds the sum of this array. So there can be one name and multiple functionalities depending upon the parameters that you pass to the function. This is static polymorphism. We can also achieve static polymorphism using default arguments. We write one function which can be called with less number of arguments. Dynamic polymorphism, we'll talk about this in more detail in the upcoming videos, but to give you basic idea, let's say we have a shape class and we have different shape classes inherited from it, like rectangle, triangle, circle. When you have multiple objects, many shapes, and these all shapes say have a function draw which draws a particular shape. And if you have an array of shapes, and if you call this draw function on these shapes, and this array has different shapes, because shape is a basic type, the array can be any shape. And when you call draw on these shapes, the functions are called according to the actual type, right? If it is a circle, then circle draw is called. If it is a triangle, then triangle draw is called. If you're not getting this, it's okay. We'll talk about this more in the coming videos. We'll talk about dynamic polymorphism. Please remember, the basic idea is you have an array of or an object of base class which can refer to object which are of derived class. The basic idea is you have a reference of base class which can refer to one of the derived class objects. Like you have a reference of shape, and this can refer to triangle, circle, or square, and you call draw. At runtime, it is decided by looking at the actual type of the object which draw function to be called. If it's being called on a triangle, then triangle draw function is called and triangle is drawn. So that's what runtime polymorphism is. And we have an interesting feature in C++ called virtual functions. We'll talk about this in the coming videos. In this video, we talked about object-oriented programming. Object-oriented programming is a way to approach complex problems where you figure out multiple entities, their attributes, their functions. You make different classes for those entities. You create objects of those entities, and then these objects communicate with each other. They call functions of each other. That's how your object-oriented software is. Object-oriented programming is mainly useful for writing softwares which are slightly complex or more complex. For simple lab assignments or simple scripts which are doing some simple automations, do not require object-oriented paradigm. We talked about classes and objects. Class is a data type which has multiple data members and functions which operate on those data members. A class basically represents an entity like student, person, teacher, course. Object is a variable of this class data type. Like int has a variable int x when we write int x. Similarly, when we wrote complex C1, C1 is an object and complex is a class. Encapsulation is a concept to bundle data and related functions together. The basic idea of creating a class, right? That's what encapsulation is. Abstraction is hiding internal details and only showing the public interface which is accessible outside the class. Inheritance, reusing the code, putting the common code in a parent class, then inheriting this code in the inherited classes or children classes. Polymorphism, same name, multiple functionalities. Two types, static and dynamic. Static is already covered. Dynamic we'll cover in the coming videos.